Before you try to memorize hundreds of organic chemical names, stop. There are only a few things you need to understand first. In this video, I'll show you how these names are actually systematic and how learning just a small set of ideas unlocks everything. Hey there, ninjas. This video is the starting point for organic nomenclature. Not the hardest rules, not the random exceptions. Just the foundation to show you that organic molecule names are structured, not random. This way, the later videos make sense. In organic chemistry, we don't name molecules randomly. We use a system called the IUPAC system. The IUPAC system stands for the International Union of Pure and Applied Chemistry, the conference of chemists that came up with this system. IUPAC nomenclature is a system that lets any chemist anywhere in the world read a chemical name and know exactly what that name represents. Before this system, every individual molecule had its own unique common name, and that led to memorization chaos. The IUPAC system replaced memorization with logic. Here is the most core idea in this video. Every organic molecule is named as a derivative of some kind of parent alkane backbone. That means if you don't know the alkanes, nothing else will stick. So why don't we start there? Alkanes are hydrocarbons comprised only of carbon-carbon single bond. There are an infinite number of alkanes as we extend these carbon chains longer and longer, and each one has an IUPAC name. But for undergraduate organic chemistry, you can pretty much stick to the first 12. The first 12 alkanes are methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane, undecane, and finally, dodecane. The first syllable in all of these words tells you how many carbons are present in that carbon parent backbone chain. The first 4 are historical. They were grandfathered in when we came up with the IUPAC rules, so you just memorize them. The initial syllable meth means 1 carbon, the initial syllable eth means 2 carbons, prop means 3 carbons, and but means 4 carbons. After that, the prefixes are numerical and predictable. Pent for 5, hex for 6, hept for 7, oct for 8, non for 9, and dec for 10. After 10, we combine 2 number syllables together to get the alkanes of size 11 through 19. 11 is undecane, 12 is dodecane, 13 would be tridecane and tetradecane, and so on. After we know the first 12 carbon backbone chains, we need to know the composition of an IUPAC name. And the logic of the IUPAC system tells us that every IUPAC name is comprised of 5 parts. They are always in this order. The beginning of the name describes any stereochemistry in the molecule. Following that, any substituents off of the parent backbone are named, followed by the parent syllable that tells us the number of carbons in the parent chain, and then a syllable to tell us about unsaturation, double or triple bonds in the molecule, and we always end with a syllable for the priority functional group if there is one. The stereochemistry and the substituents are in parentheses because those are somewhat optional. Not every molecule has a branching substituent. Not every molecule has a stereochemistry label. Every molecule has a parent, an unsaturation syllable, and a priority functional group syllable. And the IUPAC name may or may not have these first 2 parts. It all depends on the structure you're trying to name. Let's dissect the name of a simple alkane. The parent syllable tells us how many carbons there are in the parent chain, and but means 4 carbons in the parent chain. The an syllable tells us about the unsaturation in the molecule. We'll either see an, en, or yn in this position. Yn means there's a triple bond in the molecule. En means there's a double bond in the molecule. And those are concepts I go over in a later video in this series. If there are no double or triple bonds in the molecule is said to be saturated, and we use the an syllable. An means that as far as the carbon chain is concerned, there's only carbon-carbon single bonds, not double or triple bonds. And the final piece of the name is the very last E. The last syllable tells us about priority functional groups present in the molecule. This molecule has no groups at all, so there's no priority functional group in this molecule, and that's what the E syllable at the end tells us. When there's just an E, that means there's no priority functional group. And that's it. An alkane literally means a carbon chain with only carbon-carbon single bonds and nothing fancy attached. This might feel slow at the beginning, but understanding this saves you hours later. When we start to add branches or double bonds or priority functional groups, we don't start over. We modify the name of the parent hydrocarbon. There are still 4 carbons in this molecule's parent, and that tells us the name of this molecule will be a derivative of its butane parent. For now, your only job is this. Know the names of the first 12 hydrocarbons, and get comfortable with the fact that IUPAC names are built in layers. In the next video, we'll lay out the full rule set, and then we'll start doing real examples together. A lot of real examples together. You're building a solid foundation here. Let's keep up the good work.
I'm glad you're here with us for this training today. Check out these other videos in my playlists to see if there's anything else that can help you level up your ninja levels even further. As always, don't forget to like and subscribe.